I don't think transformers, the way they're built presently, are the right way to approach AGI or ASI for that matter. And here are some approaches that I think are getting close to what we want, but are not. Full disclosure, there is some sort of relevancy bias involved here because the reason I fell into this loophole of identifying what other approaches we have is because of the latest HRM paper by the bunch of Tsinghua grads who've come up with an approach that I think approaches the kind of reasoning we'd come to expect from Claude 3.5 and ChatGPT 4.0, with I think 27 billion uh, data point strong parameter base, which is much, much smaller compared to what Claude and ChatGPT are trained on, right? So maybe before I jump into why I think uh, these ch transformers are not the right way to approach this, maybe I give you a quick intro on what HRM is and what is the type of model that these grads are proposing. So, in very simple terms, the new HRM model basically tries to internalize the chain of thought reasoning mechanism that these other transformer-based tools are trying to use. So the structure they've proposed is there's one high-level module and a smaller low-level module. By smaller, I mean much less computationally intelligent. So what the high-level module does, it scopes a problem. Let's say this problem might be solving a Sudoku, for example, and identifies all the key moving parts. So, what are the steps involved in getting to the answer? What is the outcome you're expecting, etc. And the low level model is the actual solver of the Sudoku in this case, which is actually uh, taking the output of the high level module H into its low level input, which is L, and then actually doing carrying out these steps proposed by the H model, H layer, right? And so the thing that they're proposing here is different from transformers because of one, this high level and low level module is actually built into the architecture of the system. So the way transformers work, as you already know, is there is a set number of uh, no layers of nodes which are set pre-training, and these set of nodes train on a large database. And when these training sets are completed, it is then allowed to go out into the wild, and this is what ChatGPT is basically, right? What these high-level modules and low-level modules presume is that there is no reason why this number of nodes or this number of layers needs to be fixed, right? So for complex problems, you'd expect that there's a larger number of layers involved in computing uh, how a problem needs to be solved. And for a smaller problem, let's say for a text generation problem, which LLMs are excellent at, this will be a smaller set of nodes and smaller set of layers which are doing this training and testing process on, right? So the high level module itself is has access to the problem and then is also learning from the output of the low level model. So you get the loop that's working here, right? The high level module has the input problem, scopes the problem, comes up with an output on execution, sends it to the low level model. Low level model carries out this low level layer, carries out this computation, sends back its output from that computation to the high level model, which is now H input. H input again updates its reasoning process, sends it back to L. All of this is happening continuously, which means there are now double the number of sets of layers that are happening in this process. And the H level model is the one that decides when the computation needs to stop. So basically, there's n number of layers of reasoning happening that are consistently choosing whether or not to keep continuing the analysis. And as soon as the analysis, according to them, is done, they come back to you with an answer. The way this makes sense is because one, you'd want your chain of thought and reasoning to be built into your model, right? So the high level model needs to have some sort of output goal in mind, which is not only to come up with some thinking mode, which is how these chat GPT, etc. currently do it, right? So there's a thinking mode into them, which forces them to think before coming up with an answer, rather than this thinking mode being native into the AI in the sense it chooses to think before answering rather than being forced to think before answering. So this model is thinking native rather than a thinking tool called, and it has a smaller parameter set, which means for smaller problems, it is much more efficient due to there being low levels of computation data, while for complex models like Sudokus, like uh, let's say the Tower of Hanoi, etc., there will be a larger set of analysis happening due to this double system model, which has both H and L layers, right? I've probably done a poor explanation of the technical aspect of it, partly because I honestly don't understand the math behind this, but this is what I've been able to understand as a non-math person from an implementation point of view. Now, quick side note here, I think there were some concerns about this HRM model being falsely shown as being 40% on the ARC AGI test due to them using the testing data set for the evaluation, which of course does not work because training testing are both trained on the same set of data, and then you'd use the evaluation parameter data set for showing the results, which is not how it happened. So I think there's some concerns there, but this has also not been verified or disproved, so I can't really comment on whether that is true or not.